Okay, we're going over the Flipbook. Hopefully you made it to class and you're able to get all the rules and everything else filled in. Notice the Flipbook will not be used on quizzes or tests. Don't even ask me. I've already spent enough time putting them together for you other than the notes that you're going to take. I recommend that on your own time you go back to the periodic table that I've glued in there and go back to the last lecture where we colored in the charges and just recolor in all the charges so that you kind of get to know what the charges are and everything else. The common polyatomic ions is also in your notebook. It's page 10 or 11, I think. And so that's where you can have a full-sized list to look at as opposed to trying to squint on that particular page. And of course, all of this is periodic table and the common polyatomic ions list is always provided for you. You don't have to memorize anything. If you don't use what you were provided, then I may make y'all start memorizing and I'll quit providing it. So the first type is acids. Acids, if you remember, start with hydrogen. Whenever you have a hydrogen at the beginning of your compound, when you're looking at the formula itself, then you know that you've got an acid, so these are the rules that you want to use. Or if you see the word acid in the name. Okay, if there is no oxygen, you name it with hydrorootic acid. So down here, we have H2S, sorry about that. So it's hydro, S is sulfur, so sulfuric acid. That's how we name it when we don't see any oxygens. If there is an oxygen, then we have to look at our polyatomic ion list, which we just said was on page 10 or 11 in your book. If the polyatomic name ends in ate, then you change your ending to ic. If it ends in ite, you change your ending to us. And so we have, over here, we have H2SO4. SO4 is sulfate, looking at the list. So that's how it becomes sulfuric acid. And then SO3 is sulfide, looking at the list. And so that's how we come up with sulfurous acid. In acid compounds, you have to balance out your charges. So if we go back and we look at sulfur on our periodic table that we covered last time, sulfur has a 2 negative charge, which is why it takes 2 hydrogens to balance that out. Sulfate has a 2 negative charge. Sulfite also has a 2 negative charge. There all are 2 negatives. That's why we have a 2 hydrogens to balance that out. If I wanted hydrochloric acid, well, a hydro tells me that I've got the element. So that means I've got the element of chlorine. Chlorine is a halogen, so it has a 1- charge. The word acid says, oh, it's bonding with a hydrogen. Hydrogen is always a 1+ charge. Or 1 plus or minus, depending on what it's with. Because hydrogen is a plus charge and chlorine is a minus charge, they equal each other out, so that formula is going to be HCl. And you continue through like that. We have lots of practice on how to write and name these compounds to make sure that we understand. But if you keep your rules near you while you're practicing, then you'll be able to be successful when throughout the school year. Remembering writing formulas and balancing equations and everything, what we're getting into are very, very important for the entire school year. Okay, the next one is when we talk about our ionic compounds. Remember that when we have the metals and nonmetals, or when our polyatomic ions involved, there's a whole little list last time. The first element always uses the name. If it's a metal, non-metal, so if it's a binary compound where you have just 2 elements, you change the ending to IDE. If you have a polyatomic ion, you just look up the name, and that's the name that you use. So to write the formulas, you want to have the correct symbol first, and you always put the positives before negatives. You want to make sure you have the correct charge, what are the oxidation numbers, go back to that lecture that we did, And where it says drop charges and cross over, we're going to talk about that down here. So sodium, use the name of sodium. Chloride, that's chlorine, changing our ending to "ide." Well, sodium is a 1+, and chlorine is a 1-. So basically what I did is I dropped and crossed the charges. Once I know what the charges are, in order to know what's going to go first and what's going to go second. Or another way of thinking about it, your metals are always on the left side, and we read everything left to right. So if you know that you're going to do that, put your metals first, then you put your metal first, then your non-metal. And you cross over to where you have 1 sodium and 1 chlorine. We understand that there's 1 and 1, so we don't need that 1. Magnesium is an alkaline earth metal, so it has a 2+ charge. Chlorine, again, is a halogen, so it's a 1-. So when I cross over, in order to balance out my charges, there's 1 magnesium for every 2 chlorines. Well, what if we have a polyatomic ions? It's the same process. You have calcium and nitrate. Nitrate is NO3. It has a 1- charge. The subscripts you don't mess with. It's the superscript, your charge, that you're going to mess with. So you cross them over and you get your calcium nitrate. So remember, when you're working with polyatomic ions, the subscripts you do not change. They stay with whatever element it is next to. Whenever you have 2 capitalized letters next to each other, it is probably a polyatomic ion. When you have something like this, and you're going to look it up on the list. You do not have to memorize anything. Okay, the last type that we're going to talk about is our covalent compounds. That's when you have 2 nonmetals or metalloids. We use prefixes because we're not dealing with charges anymore. We have to know how many we have. So you have your mono, meaning 1, di is 2, tri is 3, tetra is 4, penta, hexa, hepta, octa, nona, and deca. The first element, just like with the ionic compounds, uses the name. The second one, just like with ionic compound, uses the root plus the "ide." So we have nitrogen trifluoride, because there's 3 fluorines, so we use tri. Notice we never, ever, ever use mono on the first element. Then you have your carbon dioxide, di-arsenic. You do use prefixes when there's more than 1 on the first. Trioxide, carbon monoxide, and then carbon tetrachloride, to represent how many of those how many of those atoms for those elements that you have. It's using our prefixes. Hopefully this was a good review for those of you who made it to class, and if you were unable to make it to class, you at least are understanding a little more of what's going on. I will see you in class for more practice and review.